Logs stacked this way create temperatures that preserve food indefinitely without any external cooling system. German immigrants in Wisconsin built cellars that stayed 38 degrees Fahrenheit for 150 years straight. No refrigeration technology, no replacement parts, no service calls. Just wood, dirt, and thermal principles the appliance industry buried under monthly bills. The archive opens in the Black Forest of Germany, 1650s. German settlers faced brutal winters with no reliable way to preserve their harvest. Through necessity and ingenuity, they discovered that earth-sheltered log constructions could create perfect food storage environments that maintained ideal temperatures year-round. This technique quickly spread across northern Europe as communities shared this life-saving knowledge. When these settlers migrated to the American frontier, Wisconsin, Minnesota, and the Dakota territories, they brought this essential preservation system with them. What's fascinating is how widespread this approach became across diverse civilizations. The Scandinavians developed jordkälare, earth cellars that have lasted centuries. Russians created the pogreb, underground log storage systems that functioned flawlessly through the harshest winters. Colonial Americans quickly adapted these techniques to their own harsh climates. The universal success of these structures wasn't accidental. They all leveraged the same physical principles. Below the frost line, Earth maintains a constant temperature between 50 to 55 degrees Fahrenheit year-round. This thermal mass acts like a giant battery, storing and releasing heat slowly to create stability. The soil layers provide natural insulation that buffers against external temperature extremes. The log construction itself is where the real genius emerges. Horizontal stacking creates natural thermal breaks that prevent heat transfer. Wood provides excellent insulation properties, and the careful spacing between logs allows for controlled ventilation, critical for preventing mold and spoilage. The ventilation system works on simple physics. Cold air intakes near the floor level allow fresh air to enter, while warm air exhaust points at the ceiling create natural convection circulation. No fans, no electricity, just the laws of thermodynamics working perfectly. The performance data is remarkable. These structures maintain temperatures between 32 to 40 degrees Fahrenheit, regardless of outside conditions. They create ideal humidity levels between 85 to 90%, perfect for food preservation. All this with zero energy consumption and virtually no maintenance requirements. When you look at the economics, it becomes even more compelling. A traditional root cellar costs between $500 to $2,000 in materials and can last over 100 years. Compare that to modern refrigeration. $1,500 for the appliance, plus $200 per year in electricity, plus replacement every 15 years. Over just 30 years, that's over $15,000, and the costs continue mounting while the root cellar stands strong for generations. Then 1918 arrived, and everything changed. General Electric began mass-producing home refrigerators, launching sophisticated marketing campaigns that positioned their products as modern conveniences, while dismissing traditional storage as primitive. Government programs actively promoted electrical grid expansion, creating infrastructure dependence. What emerged was a $150 billion refrigeration industry built on a dependency model. Appliance sales every 10 to 15 years, ongoing electricity consumption, repair and maintenance contracts, and replacement part sales created a perpetual revenue stream that traditional methods didn't generate. The burial of this knowledge was systematic. Building codes made no provisions for earth-sheltered food storage. Health departments created regulations favoring mechanical refrigeration. Insurance companies charged higher rates for non-standard food storage methods. Real estate appraisals assigned zero property value to root cellars. Agricultural extension offices stopped teaching traditional preservation techniques. The cultural erasure was equally thorough. Home economics classes removed root cellar instruction from curricula. Society attached an old-fashioned stigma to earth storage. Children's education focused exclusively on electric appliances. Within a generation, knowledge that had sustained communities for centuries nearly disappeared. But the numbers speak so clearly that institutions eventually had to document them. USDA Agricultural Research Service studies confirmed that properly built cellars maintain optimal 32 to 40 degrees Fahrenheit temperatures. They documented superior humidity control compared to mechanical systems and measured zero energy consumption over decades of operation. University of Wisconsin Extension research monitored 19th century cellars, still functioning perfectly. They recorded consistent temperatures through extreme weather events and validated that food preservation was equivalent to modern refrigeration methods. International validation added further credibility. European Union agricultural guidelines now include earth storage recommendations. Scandinavian countries maintain root cellar building standards in their codes. Canadian agricultural colleges teach traditional storage methods alongside modern techniques. Climate research has provided the final confirmation. Earth-sheltered storage reduces food waste by up to 40%. It creates zero carbon footprint compared to refrigeration's massive energy use. And it remains resilient during power outages and equipment failures, increasingly important in our unstable climate. Despite industry efforts, current practitioners continue this tradition. Homesteading communities across rural America rely on these systems. Montana families store 8 months of vegetables in their cellars. Wisconsin organic farms use century-old cellars that continue functioning perfectly. Alaska residents maintain food security off-grid through the harshest conditions. The permaculture movement has sparked a revival. Root cellar workshops are filling up across 30 states. Online forums share construction techniques and troubleshooting advice. YouTube channels document successful builds, inspiring others to reclaim this knowledge. Commercial applications are emerging as well. Organic farms reduce refrigeration costs by incorporating traditional storage. Restaurants use root cellars for specialty ingredient storage, noting improved flavor profiles. Breweries age products in earth-sheltered spaces to achieve distinct characteristics impossible with mechanical cooling. Internationally, the resurgence continues. European eco-villages build community root cellars as central infrastructure. Developing nations choose earth storage over expensive refrigeration systems. Climate-conscious families reduce energy dependence by implementing these time-tested methods. So how does earth-sheltered log construction actually work? Site selection is crucial. You want a well-drained hillside location where you can dig 6 to 8 feet below grade to reach temperature stability. North-facing slopes are ideal to avoid direct sun exposure. Materials are straightforward: pressure-treated logs or naturally rot-resistant wood like cedar, gravel for drainage foundation, vapor barrier and insulation materials, plus ventilation pipes and basic hardware. The construction process involves excavating into a hillside at the proper angle, installing a drainage system and foundation, stacking logs with proper chinking and sealing, setting up a ventilation system for air circulation, and finally backfilling with insulating earth layers. Cost-wise, materials run $500 to $2,000 depending on size. Labor can be a DIY weekend project, or you can hire an excavator for the initial groundwork. Tools required are basic carpentry and digging equipment most homeowners already have. Maintenance is minimal. Annual inspection of the ventilation system, occasional log treatment every 10 to 15 years, and drainage system clearing as needed. Compare that to refrigerator maintenance and replacement cycles. The deeper principle here reveals why this knowledge was suppressed. The refrigeration industry spent the 20th century selling dependency. Their manufactured obsolescence model ensures appliances fail every 10 to 15 years. Proprietary parts require professional service. Energy consumption creates monthly utility dependence that never ends. Root cellars offer complete independence. No monthly electricity bills, no service calls or repair contracts, no replacement cycles or upgrade pressure. They provide food security during power outages or supply disruptions, increasingly common in our changing climate. The self-sufficiency versus corporate control dynamic becomes clear. Families who preserve food with earth storage buy less from the industrial food system. Communities with root cellars are less vulnerable to supply chain disruptions. Knowledge of traditional preservation directly threatens processed food profits, explaining the systematic erasure of this information. The truth is, this knowledge was never lost. It was just never sold to you. German settlers knew this in 1650. Your great-grandparents built these routinely. The physics hasn't changed, only the marketing has. The resources to reclaim this knowledge are readily available. Plans from agricultural extension offices, books documenting traditional construction methods, and online communities sharing successful builds make this accessible to anyone willing to learn. The choice you face is clear. Continue paying $200 per year for refrigeration electricity and replacing appliances every 15 years, or build once what your ancestors built to last centuries. If you're ready to start, Excellent resources include Root Cellaring by Mike and Nancy Bubel, state agricultural extension publications, and permaculture forums and workshops where hands-on learning happens. What shocked you most about this buried knowledge? Tell me in the comments what you'd store in your own root cellar. Subscribe now. Our next lost build might save your family during the next grid failure.